Recording. Where was I? So we've done lesson one. Lesson two, we're going to look at algebra and solving equations. So if we've got an unknown, how do we figure out what it is? All those kind of things. And that'll be lesson two. Lesson three, we're going to, if I remember, I think that's the one on percentages. So we kind of get in percentage. So it's not necessarily important that you have this one. So it's almost like some of these things we could do in different orders. And then lesson four is modeling, which actually will look back at lessons 2 and 3. So some of the techniques I'm going to show you with Desmos that we're going to use today also apply to lesson 4. So it's like you're getting a jump start on it. If you follow along today, like 4 will be, oh, okay, we kind of already did that. So we'll add a few things to it, but the techniques will be the same. And then lessons 5 and 6 are both financial math. And I don't have you do formulas with that because that's not how the financial planners do it. They use a financial calculator. So we're going to provide online financial calculators. There's the same one you can download to your phone, which I highly recommend because I don't know about you, but if I don't have my phone with me, I can't do anything. Literally, I can't even log into my systems because you got double authentication. So it's like we have to have these things with us. Why not have them be able to do everything we need them to do, right? Financial math. So you walk in, oh, there's a beautiful car, I want to buy it. Well, you got to get a loan. You'll be able to figure out that they're not taking you to the cleaners on that loan. Okay, so we do that 5 and 6, and then we'll have our midterm. So, and again, we've got each week we're doing one lesson, so we've got about 5 more weeks ahead of us. We'll have a week for review and test, and we're all in good shape. Then after the midterm, we do some new topics, and we're not going to come back to these particular topics, but so just think of this class. It's not, even if you miss one, and I gave extra credit the first day, right? So I haven't actually looked at those yet, so I will and score them. But that first day, if you did that extra credit, you have a whole week's worth of points that will be there for you. So if you decide I don't like that week, let me just skip it, you could do that. Okay, so for lesson 2, what I'm going to do is I don't have a PowerPoint for it. What I want to do is also show various ways of learning, and one way is actually having a book. I'm going to download it because it's easier that. I'm going to just kind of walk through some of the examples in the book as it goes through. I will discuss them. I'm not just saying read the book, but I want to show you how the textbook really has an outline of what we're doing. We'll talk about it, and we'll use the textbook as our outline. That's really what I do in when I'm using a PowerPoint anyway. It's really just an outline, making sure I covered everything I wanted to cover. So download, see, here we go. I think what I will do is I will bring up my alternate writing tool. It is Epic Pen, so this is another one. So they have all these different things you can download, some for free, some you pay. I think I paid like $2 for this one, and it lets you write on your screen. Let's see, let's go with this. Let's make it bigger. Maybe not that big. There we go. Okay. So we're looking at solving equations. So we'll talk about that. We're going to look at linear equations. And then we'll look at application problems involving equations, sort of how to set them up, and slope-intercept. So they're all kind of related back to that. So here it is. Again, just kind of my outline, and you can see there's going to be some examples in the textbook, so you can bring these up. I'll give you a couple examples. So first of all, let me ask you, is that an equation? No, what's missing? It needs an equal sign. Without an equal sign, nothing's it's what we would call an expression, but it's not an equation until we have an equal sign. Now is it an equation? So it also needs what? Something on the other side, right? So now it's it's a full equation. It's got the equal sign, and the equal sign is a relational sign. It's telling you how one side is relating to the other. And if you get in a full algebra class, sometimes they use greater than or equal to or less than, so they got all that. We're just going to go with the equals so that both sides are the same, right? So it indicates balance. Well, where we're starting is, this is kind of the second level. We're going to go for the first level. If I had x plus 3 equals 12, how could I go about solving that equation? Could subtract 3. So I do the opposite. This is where I say, if you were kind of like a rebellious youth, which parents said do this and you did that, you're good at algebra, because algebra is all about doing the opposite. They tell us to add. No, we're going to subtract when we go to solve anyway. And again, we do it from both sides. Why is that? Because if they're equal, they're balanced, and as long as you do the same thing to both sides, they keep them equal. Okay? So again, that's a way of solving. X equals 9. Some of you might look at, well, something plus 3 equals 12. Maybe you just visualize that's got to be 9, because I know 9 plus 3 is 12. That's another way to do it, but this is a formalized way, is if you just sort of do the opposite operation to both sides, you'll be able to solve for x. Okay, so if we have addition, we subtract. What if we had subtraction? What would we do with this one? Add. We would add, because that's the opposite. Oh, but you add the same number, not... I've been doing that a lot lately, where I think one number and I write a different number. I don't even know where the 9, maybe the 9 came from here. That's what right? So we get x equals 44. Now we know what it is. We could plug it back in. We could test it. So we could evaluate, plug it back in, 44 minus 7, and I always put the equal sign with the question mark. Does it equal 37? 47 minus 7, that's 37. Yes, 37 is equal to 37. So we kind of see that that's the right answer. Okay, so these are called one-step problems. So notice we take one step and we're done. There's another type. Let's see, I think I have to clear this off. That's one thing I don't like about this. That's okay. Oh, I know. I don't need this one if I'm here. Well, I can also use this one. Word has a built-in draw program, so here's another one. What if I had 3x equals 10? How would I go about solving for x here? Divide 3 on both. Okay, so we see that we're multiplying by 3, so the opposite of multiplication is division. 3 divided by 3 is 1, so we end up with x equals 10/3, or 3.33333. If you want to iterate it to a calculator, that's fine, but we could just leave it as 10/3. If we're dividing, how do we solve this one?
2 over 1, you multiply.
Multiply by what?
Across.
Okay, you could do it that way. So we can, when we have two things equal, we can cross multiply. We might get to a place where we need something. What would be another way? It's not that that's wrong. We could cross multiply. Yes. Good. So multiply both sides by 5, because the opposite of division is multiplication. And I like to think of it as 5 over 1, because when we have fractions, we want to know whether we're in the numerator or denominator. And then we could do the division first. Think of this as 5 divided by 5. That will cancel out. And so we get x equals 10. And notice, yes, we did 5 times 2, and then 1 times x. Cross multiplication also works. It works beautifully. And I'm going to use that a lot when we get to percentages. So, but in this one, we might need to be able to think of it in more ways than cross multiplying. So far so good. Those are all, we did all the types of one-step problems that there are. We're either going to, if we got multiplication, we divide. If we've got division, we multiply. Subtraction, we add. Addition, we subtract. So then we've got the two-step. And so that means there's going to be two steps. And we'll go back maybe to this one we started with. So we got 2x plus 4 equals 5. What would you think would be the first step we'd need to do? Yes. Subtract. Good. So subtract the 4 because we're trying, good. We're focusing and trying to get the x by itself. Good. And we want to do the opposite to the 4. So not only do we do the opposite, but notice we're doing it in the opposite order of operations. Usually you're supposed to multiply and then add. We're adding and then multiplying. So we're complete rebels here. Yeah, we don't listen to anything they're saying. We're always going to do the opposite. Opposite order too. Good. So we take care of the addition part. We're going to subtract 4 from both sides. So we get 2x equals 5 minus 4 is 1. Now what would we do? This is now kind of down to a one-step problem. We're multiplying by 2, so we divide by 2. Okay, so yeah, and you'll see if you're doing the right thing, what happens on the side of the variable is things start disappearing, right? 2 divided by 2 is 1. That's what we're trying to make happen. The other side is just 1/2, or if you want it as a decimal, 0.5. You'll see when we get to percentages, I like the 0.5. I like decimals. It's a little easier, but we can work with fractions too. Okay, so that's just a double step. Do it in the opposite order. You ready for a challenging one? Let's go with this one. What do we do here? Multiply by 2, because we could think of this as a two-step problem. Okay. So we're dividing by 2, so let's multiply by 2. That works. 2 divided by 2, right? Now we have 3x on this side, and 4 times 2 is 8. Now what do we do? Then divide by 3. Okay, so good. Thinking of it as a two-step problem, we just do it in that order, and we get x equals 8/3. Now, that all works, and that's beautiful. But sometimes we like shortcuts, not always. But what if I told you there is a one-step process you could do to solve for x?
You just take 3 halves and put on the other side.
So we think of the reciprocal as being maybe the opposite of a fraction, right? So the opposite of 3 halves is 2/3, and we could do this sort of in one step. Again, it doesn't have to be. I oftentimes will think of it in 2 steps, but we could also, if we want to shortchange it, we could multiply by 2 and divide by 3 at the same time. Good. Sometimes we forget, and again, whichever method, and so 3 divided by 3, 2 divided by 2, that gives us our x, and 4 is 4/1, so that's 8/3. Notice we got the same answer, but it happened sort of in one step, or 2 steps being done at the same time. So however you want to do it. But sometimes that's where people get stuck, is they'll see a fraction and they go, I don't know what to do next. Multiply by the reciprocal. That's our power against fractions. It wipes them out. Or in 2 steps. Okay. So far so good? Okay. Let me check back on the textbook, and let's see if we've done what we were supposed to do. So we talked about the algebraic equation needs an equal sign. They use a lot of letters and they give all this stuff, but here's some examples. We could have used their examples. They've got 2/3, I use 3/2. And then they will walk you through the solutions just like we did. Okay, so I just chose different solutions or different examples, but yes, that's exactly what the textbook has them doing, or what the textbook is doing. And notice here, they went for the one-step solution, 2/3 multiplied by 3/2, and all of a sudden, you're solved. Okay, there's some you-try problems, so again, in the textbook, if you want more practice, you've got those. If you've got it down, you're fine. And then they get into the multi-step. Again, here's 2 steps. Here's 2 steps, so, and again, they'll show you the solutions, so that's in the textbook. You can always look at those and kind of hopefully be able to follow along with what they're doing. So yes, they're subtracting the 7 first and then dividing by 2 and so forth and so on. The one that I realize I have not done yet, they got some application. Maybe they don't do the one. Oh, I guess we don't have to. Well, let's take their example. So this will help us, because there's a few homework problems where they give you a word problem. Okay, so when I look at a word problem, what I typically like to do is try to work backwards. So what I mean by that is I'll come and I'll read the first sentence first. So determine the age of a person whose target heart rate is 33 beats per minute. So at least now I know, okay, what am I looking for? The age of somebody whose heart rate is 33 beats per minute. So at least I know what I'm looking for. I don't know anything else if that's all I read, but I know that. And then I come up here and I see a formula. I see a T and an A, and I know I'm looking for an age. Hey, age, A, years of age. So A is standing for their age, how many years they are. And T, I see that, is beats per minute. And again, I've got, okay, I'm going to be given the beats per minute, but I want to find their age, and here's a formula. Now I could go up and read the rest, but it's all going to be a story problem. But notice I kind of skipped over the first part. If you read like they teach you to, you read all of this. But the problem is you're reading about heart rates and stuff, and then you're wondering what do I need to know? Did you have a brother or sister who pulled the bus joke on you? I'll pull it on you right now. So I'm driving a blue bus, and 3 people get on at the first stop. At the second stop, 1 person gets off and 2 people get on. I go to the next stop, 5 people get on, 2 people get off. You're thinking so you start calculating, right? Because you think I'm going to ask you how many people are on the bus. I don't. What color was the bus? You forgot. Well, some of you remember blue. Okay. I always will forget because I was trying to calculate how many people were on the bus. So that's the thing, is if I asked the question first and I told you I'm going to ask you what color the bus is, you'd know what the color, and you wouldn't even pay attention to the people getting on and off, right? That's what that's what some of these questions are, is you start reading and you start thinking all these different, all this stuff goes through your head. And then at the end, it's a simpler question than what you probably started working out, okay? So the thing is I can read this. It gives me, information, but I also know I've got a formula. I know that T is target heart rate, and I know that's going to be 133. So I can start setting that up. T is 133. 0.7, this is just a formula, and my A is the age of that person. That's what I'm looking for. I'm solving for A. So had they just given you this equation and said solve for A, that's all we needed to do. And a lot of times that's easier to do, right? Because it's all set up and just solve for A, so we could do that. But the word problems, where the problem comes in, is we start reading and we got all this stuff and we got lost, right? Because remember from my first day lecture, where does that go? That goes to the amygdala. And then maybe we got stress or something, or I don't like exercise. Then I start thinking of gym class and I hate, whatever. You get all these other things going on. Now we just got the math. So in this one, this is a little different than what we've been doing, but what should we do first here?
Distribute the 0.7.
You could distribute the 0.7. Do we have to? What could we do instead of distributing? We could divide it, right? So this is the thing, there's nothing wrong. With algebra, there's oftentimes more than one right way to go about things. So yes, you can, and typically we're taught, okay, distribute, but what we're going to see is if we kind of break the rules of what we've been taught, it actually might be a little easier. So if I take 133 divided by 0.7, notice over here, this is going to cancel, so I don't have to, actually I'm going to save myself a step this way. So all that's left, since that's gone, is 220 minus A. What's 133 divided by 0.7? Oh, I left them in my vehicle. Has anyone got that for us?
190.
190. So we've got 190. What should we do next to solve for A? Getting A by itself.
Oh, subtract 220.
Subtract 220. 220 is positive, so if we subtract it, it will get rid of it. So that's gone. 200 minus 190 is 10. Negative 10 actually equals negative A. And what's A supposed to be? It's supposed to be the age of a person. Well, can a person be negative 10 years old? Oh, there's a negative here. So that's like a negative 1, isn't it? How do we get rid of that negative 1? Divide by negative 1. So we end up with A equals positive 10. So the age of that person, so that's a 10-year-old person. Should have a target heart rate of 133, according to this formula. We good with that? Okay, so again, you've got some creativity that you can do. You could choose to distribute the 0.7. You could choose to divide that first and then maybe save a step, whichever feels most comfortable for you. Okay, but just when you have these word problems, if you'll get in the habit of sort of, like I said, reading it backwards, read the last sentence first, I think you're going to find it makes a lot more sense, and you're not steered in the wrong direction. The problem is after 3 sentences and notice the first 3 sentences, it doesn't really get into anything that we're supposed to do. It's just telling us about the heart rate and exercise and blah blah blah, but it's to solve the problem. It's not what I need. Okay. Good. All right. So that pretty much will take care of the solving. So there's these, and now we're going to get into linear equations. We'll go here with a little bit. A linear equation, actually we solved a few of those. Something like 2x plus 4 equals 5 or equals something. This is a linear equation, but what we're going to introduce here is we're going to make it a true relationship. We'll introduce a new variable that x could be more than just one answer. There's going to be more than one answer for x. So as I put in a number for x, y will change. Okay. So this comes from situations like on our power bill. We have things like cost per kilowatt hour. We know the more hours I use electricity, the higher the cost is going to be, right? So there's what's happening here is 15.4 is going to be what I multiply by, right? So my linear equation here is y equals 15.4x. X is the number of hours I've run my air conditioning. whatever, right? I multiply by 15.4, that's going to give me the cost. How many kilowatt hours, right? That's how many cents. X is kilowatt hours. I'll get that. Concert tickets, cost per ticket. If it's $155 per ticket, that seems like a lot to me. Is that about a normal cost of a concert?
It's low.
It's low? Whoa. I think my first one I paid 25 bucks. Of course, that was back in the 80s, but I'm cheap. Okay, so that's a low. Well, okay, big name tickets. Okay, so this would be like the cost is going to be equal to 155 times however many tickets you buy. You're going in with 10 friends. That's going to be $1,550, right? So again, it gets us a linear equation. If on the treadmill, miles run per minute, so you can run about 1/10 of a mile per minute, y equals 0.1 x, where x is the number of minutes you've been running, you can calculate how far you've gone. Okay, so those are what we call, these numbers in front of the x, notice, are rates of change. So it's the rate, it's how quickly things are changing. So that's one concept we need for the linear functions. Okay, so we're going to go over this. The other thing, how many of you are familiar with the formula y equals mx plus b? Somewhat. So that, again, it comes, if you've ever taken an algebra class, you've probably seen this because it's always in the, it's in beginning algebra at some point. The thing is, remember I think I talked to you all about where does math come from? We talked a little bit about India. And India, the Arabs went to India to learn math, and they developed something called algebra. And they wrote a lot of books on algebra, but in Arabic, the sentences read from right to left. They read in this direction. So in Arabic, when you see this equation, the Arabs are actually reading it in this direction. They see the b first, b plus mx, right? So sometimes you'll see books that have actually transposed it and do this way for us English readers who are reading in the opposite direction. Because the parts of a linear equation, you have the output, or the answer, right? That's the y. You have the rate of change, or the slope. You have your x. So I'll put rate of change. And again, that might be, if you're paid hourly, you're paid $15 an hour. You multiply by the number of hours you work. But there's always this starting value. Okay. Sometimes that might be 0. You show up for work and that's when you start getting paid. But you might get paid a fee. Maybe you've got your own business and you're a window cleaner. You charge $20 per window, but you charge them $45 to come out, right? So that's that. What I say, $25 per window. That equation would look like 25x, however many windows they have, but I'm going to charge you a start fee of $45. You're going to call me out. I got to pay my gas. I got to do this. It's $45 just to come to your place, and then I'll charge you $25 a window. Okay, so all those kind of equations come from this. How are we doing so far? Is it making sense? Getting there? Okay. Again, we'll get some chance to go through some of the homework problems as well. And the connection between what the slope is and what the graph would look like. If the slope is positive, right, $15 an hour you get paid, the graph is going to be going upwards. So that's positive. If the slope is negative, you have to pay $15 an hour to sit or something, then it's decreasing because your money's going down the longer you're there, right? It's a negative slope. If we have a 0 slope, that's horizontal, and there's no change, that's a constant. And then there could be a vertical line, but that's where slope is undefined. We'll talk a little bit about that. But for these, we just get, let's see, this one, our equation would be y equals a number, say y equals 3, we'll get a horizontal line. And if we have x equals 7, that's a vertical line at 7. So there's x equals 7. Let's do it this way. This would be x equals 3, horizontal line. Okay, so those are, sorry, y equals 3. So those are two sort of extreme examples. Everything else will be something like y equals mx plus b. Okay, and so we're going to get a graph that either goes up or down depending upon what the slope is. And then remember, the value of b is always sort of where it starts. It's where it goes through the y-axis. Okay. So we've kind of diagrammed it that, come down a little bit. So for y equals mx plus b, we know that m is our slope, our rate of change. And that b is our starting value. So it's a place when x is equal to 0. So I'm going to put that here, 0, comma, b. We always get that point. So this is just sort of defining things. If we have this equation, the number in front of the x is going to be our slope. And since it's positive, it's increasing, right? And then the vertical intercept, or the starting point, is going to be 0, 5. Because if you plug in 0 for x, you get 3 times 0, which is 0. You get y equals 5. So that's our vertical intercept. This 5 comes directly from here. Okay, so I can look at the equation and I can tell what's going on. Here,
Sorry, what's the initial value?
Initial value is the vertical intercept. It's the same thing. So we use multiple words for the same thing. And we call it the starting value because oftentimes x is time. So when x is 0, that's the start. Okay, so that's. But those are my words, not the books. A lot of books don't use that word. Okay, so here, notice that it's the number. They've switched the order, right? But there's like a -1 in front of the x, so that's why the slope is -1. Since the slope is negative, it's going to be decreasing, which means it's going to go down, increasing when it went up. And then our vertical intercept, or starting value, I'll put that here. Comes from right here. It's the number without the x, and it's a +8, so it's going to be 0.8. This equation, y equals 2x, there doesn't seem to be that extra number, but we could always put a +0 here, right? 2x plus 0 is the same thing as just 2x. But again, we see the number in front of the x is our slope. Since it's positive, it's increasing. And then the y-intercept, the vertical intercept, the starting value, it's starting at 0. So that's 0, 0. When x is 0, y would be 0. And finally, this one, notice there is no x. Why is there not an x? Because there's really a slope of 0, 0x. So the slope is 0, but when you have 0 times x, you get 0, and it just sort of disappears, and we don't have anything there. But that's the way to think of it. We do have a number, -8, so that's our vertical intercept, our starting value, 0, -8. And again, we can look at these and we can maybe visualize what each of these graphs are going to look like. So this would be a horizontal line at -8. And we're going to use a graphing software. We're going to use Desmos.com to do some graphing here in just a moment. Okay. So again, these are just, there's some problems in there. We'll have you kind of work through those. We'll work through a couple together when we go through the quiz. But here's this way of getting the linear equation when we have 2 points on a graph. So oftentimes in solving a problem, we have 2 sets of pieces of information. So in this case, we've got a population of a city in 2 different years. So they're letting X be the year. And we've got 2 different years, so 2002 and 2006. X1, Y1, so 2 different years. What we're going to, I'm going to make it a little easier. What we have is, when we have years like 2002, that's a pretty big X value, right? 2002. Oftentimes what we will do, and sometimes they will tell us exactly what, we will change the year to be years since some other time. They're not going to do that directly here, so I'm going to do it for us. So we could say that, let's say time started, yeah, let's see, maybe I don't want to do that. Let's say we'll use 2000 as equaling year 0. So what would 2002 be if 2000 was year 0? Just 2, right? So easier to work with, and that makes 2006 just year 6. So a lot of times we can do these calculations. What I'm going to show you is that we can get the slope, we can get the y-intercepts from these points. And at the same time, visualize it by using the calculator. Oh, I've got to clear this stuff out. Okay. At Desmos.com. And again, this will also be something we're doing. So if you go to Desmos.com, we want to use their graphing calculator. We have this come up. What we're going to do is we're going to hit this plus sign because we're going to actually put in a table where we enter in the points. So x1 would be our first point, which was 2. What was the second? What was the y value? 23,000 something? 400. We're going to put that in there. And then we're going to put the next year, which was year 6, and 27,800. Okay, so I put in my 2 points. To get the equation, now I don't see anything, but notice these are pretty high up here, right? Let's see, let me move. Everything's in my way. There we go. So I know the y values are going up. So if I have my y values go up to say 30,000, right? I actually can now see my points. 2, 23,400, 6, 27,800. What I'm going to do is now I want to add an equation, an expression. And what I'm going to do is, notice the y value is y1. So I'm going to enter y1. And then under here, I'm going to use, instead of equals, we'll use approximate, this little tilde symbol. And then what's the general form of the equation of the line? Y equals mx plus b. Watch this. I'm going to put in m. I'm going to put in x, but not just x. What kind of x? x1, because I want it to go look at this table. So then I come back here to the numbers and I put 1. And it just puts it down for me. I didn't have to do anything. I just, right next to the x, I put in 1. Now it knows I'm looking at this particular table. But I'm not done with my equation yet. I have to do plus b, right? So I'll do that, plus b. And I'll come back to my letters. There's b. And now, notice what it's done. It actually drew the line. That's kind of cool, and it goes right through those 2 points. I see them. But it also gave me the equation of the line right here. And so I could write that equation. I know that m is 1,100, b is 21,200. So I know that the equation is y equals the slope times x plus the b value, 21,200. And now if I wanted to find out what happened in year 2010, right, that'd be 10, I could plug in 10 here and I could calculate it. So that's the kind of thing, but I've got the linear equation. And that's the kind of thing we're going to have you do in the homework, is we'll give you 2 points, ask you to find the linear equation. And if you just open up this is just at desmos.com. You could do \calculator, you go right here, or just click on the graphing calculator. And you're going to see we're going to use this a lot as we get into lesson 4. Let's skip it a little bit, lesson 3. But we're going to do this because it gives us the ability to come up with an equation given 2 points. Any questions so far? We doing okay? Okay. So what I'm going to do right now, since we got I want to give you some time to get started if you want to get started. So I think we're ready for the quiz, because the quiz will tell us what we need to know, right? And then we've got the time, and then this is Thursday. What do we do on Tuesday? Work on the homework. It's a work day. If you're done with it already, or you're on track with it, and you don't have to. I like to make education about choices, right? You're not going to be penalized as long as you're learning the material, right? You don't get penalized anyway, but oops, not the homework. We could do the homework, so there's a bunch of questions in here. We don't want to do the homework though, because that's way too many problems. We just want to do the quiz. And again, when you do it, you'll get slightly different questions. Let's see, usually there's 5 or 6. There's 6 here, so we'll kind of work through these just so that we know, okay, that these are what we went through. Let me make it bigger. How's that? Okay. Oops, what happened here? This looks like r minus 9 divided by 4 over 6, right? Let me make it a little bit bigger. So this first question, r minus 9, I'm a little worried about this little thing in front, that it might be something more. But we'll see. Okay. And so we're asked to solve for r. What would we do here?
Multiply by 4.
Very good. Multiply both sides by 4. 4 divided by 4, that cancels. R minus 9 equals 24. And then what would we do? We would then add 9. And again, if you want to open it up and start working through it, that's fine. If you want to just follow along, that's 33. And we'll submit, and we got it right. Question 2 looks like one we already worked, right? I don't know what this little, it's like it's missing something. But we've got a formula, m equals 0.8, 220 minus A. A is the age, beats per minute. Instead of 133 this time, we're looking for 144, or 140. So we just set it up, 140 equals 0.8 instead of 0.7. 220 minus A, and we need to solve for A. So how do we go about doing that again? Divide by 0.8. Again, you could distribute, but you'll find it's a little smoother if we do it this way. 140 divided by 0.8 is going to be 175. Got 220 here, minus A, and then we're going to subtract 220. So we get negative 25, 45, negative 45.
Yes.
Equals negative A. And then remember that that negative in front of the A is like a negative 1. So we divide both sides by negative 1. Because who could be negative 45 years old, right? And then A is equal to 45. So the age of this person is 45 years old. And I could either submit it, or in the teacher version I just click on this and it'll give us the answer too. So either way. Okay, so that's similar, it was but a little bit different. 0.8 instead of 0.7. Find the slope between these 2 points. I'll show you how you can do that with a calculation, but we could also go to Desmos and do it. But I'll show you something a little different, and a little different than the formula that you might be used to, y2 minus y1. What you do is you take one of the points and you list it first. So I'm going to take 2, 7. I'm going to put that up, list it as a point. The second point is negative 5, negative 3. And to find a slope, remember we were subtracting the two variables, subtracting y and subtracting the x. So once you've got it lined up like this, if you'll subtract, so 2 minus negative 5, if we're going to subtract negative 5, that really becomes a plus 5. So 2 plus 5 is 7. And then this negative comes here. We're going to subtract negative 3. So 7 plus 3, that gives us 10. And remember, this is the x, this is the y. So if we take the x and tuck it underneath the y, we have our answer. We have our slope is 10/7. It works on any 2 points. Because it really is, it's the same thing as the slope formula. It's just it comes from India. They did things visually. It's a visual way of doing it without having to put it into a formula. It will always work. It's the way I use now because I usually won't make a mistake this way. If I use the formula, I'm very error prone. Let me just show you. We'll do the same thing, 2, 7 and negative 5, negative 3. We'll come back here. This is already set up for us. Was it negative 5, negative 3? Did I get that right? In the right order? Good. Negative 5, negative 3, and then 2, 7. I'll put in 2, 7. And now I don't see the points, but if I come down here and I reset my window because I'm way up at 17,000. Let's go down to 10, minus 10. to 7. Oh, here it is, -5, -3. So I've got the 2 points. I've got the line going through there. And it gives us the slope is 1.428. So if you take 10 divided by 7, right, that's what you'll get. So you could do it that way. I think it'll take either one. Let's see, 1.428.7. No, 1.42857. I don't know if it'll count it right or not. Let's see. Yes, it counts it right. Or we could just put in 10/7. Okay, so two ways of calculating the slope. If all we need is a slope, take your 2 points, subtract the x's, subtract the y. The y goes on top, the x's go on the bottom. So this way, you do the subtraction, tuck the x underneath the y. And if you get comfortable with this method here, it's less error prone. Or use the Desmos calculator, because once you get it set up, all you got to do is change these points and it will calculate the new equation of the line for you. Okay. We're almost there. Okay, so let's just go. So this one's wanting the rate of change and the initial value, which is also the vertical intercept, which is the y-intercept, which is the number by itself. Okay, so it's all those things. Go with this one. So in this equation, which of these numbers is our slope, is our rate of change?
10.
10 is it. And then, so that goes in under rate of change. Initial value, that's the -8, the one without it, but we list it as, I think just not as an ordered pair, but that's the starting value, initial value. And then what is the behavior? If we click on this, oh, is it decreasing, horizontal, increasing, or vertical? It's increasing because the slope is positive. Good. So it's going to be going up. Okay. Incidentally, I'll just show you, you could also use Desmos to just graph something like this. So we could just, I don't think we might need this, but let me turn this one off. Let me go with y equals 10x minus 8. And again, we'd come out. So we can see it's intersecting here at 0, -8. And it's got a slope of 10. So it does show us what it looks like. Okay, so you can kind of, and it's increasing. Okay, the next one, what is our rate of change? Is that 9? Good. I was throwing you off there. What is the rate of change?
7.
-7. So it's going down. So it's always the number in front of the variable. So when they move the order, it's not always the first one. So be careful, because that's what oftentimes at the beginning people say, it's always the first number. No, it's always the number in front of the variable. So -7. What's our initial value? That's the one without the variable. That would be 9. And is this increasing, decreasing, or something else?
Decreasing.
Decreasing because the slope is negative. Okay, so we kind of just go through and do that. These next two might be a little challenging. Y equals 2a. Remember, that doesn't look like, so I'll just do this. The slope is 2, but it looks like the initial value, what would that be?
0.
0. That's why it's invisible. There's really a +0 there, but it doesn't show up. So I'll just, yeah, it's really like +0. So our initial value is 0. And is this increasing, decreasing, vertical, or horizontal? It's increasing because it does have a slope of 2. Horizontal will have a slope of 0. So that's okay. So good. I'm glad we did these ones because that's what I was thinking. And then this last one, there is no variable. There's no x. So what is the rate of change? Very good. So that one's a 0 because it actually is there. It's just invisible. It's like plus 0x. Okay, so that's what a slope of 0 looks like. The initial value, that's the number without a variable. Excellent. And so this one, what is it decreasing, increasing, horizontal, or vertical? This is the one that's horizontal. And again, we could come back to Desmos, and we could graph y equals -4, and we see, yes, indeed, it's a horizontal line down here. So sometimes it's good to use the graphing calculator, the built-in thing to here.
When is it vertical? Y equals what?
X equals, there is no y. Y becomes a 0. And the nice thing about this one, a lot of graphing calculators won't do this, but this one will. I can graph x equals 5, and I can see it's a vertical line. So there's another way we can kind of use the tools to verify things. Yeah, when x is always 5, so that's going to be up and down. No y in there. Good job, good job. Okay, so that was question 4. We've got 2 more to do. We've got an equation here. It's a balance in your college payment account after Q quarters, and we can see that each quarter is costing us about $3,200. So our balance is going down. Interpret the slope in this situation. The balance in this account, what's happening to the slope, or with the slope? The slope is it's decreasing. It's going down. What's the rate? It's decreasing by 3,200. And even though the slope is negative 3,200, we put the rate as 3,200 because when we put this word decreasing, that's where the negative comes. That's the negative. And what is it? Oh, they want us to have units. This must. Well, they didn't really tell us. If we're in Europe, maybe it's euros per. But it's per quarter, right? So it's dollars per quarter. That's how much it's costing us. Interpret the initial value of the situation. So the initial value is the one without the variable, right? 48,000. What does that mean? When is the beginning? How many quarters have we spent in college at the beginning of our college career?
48,000.
We have 48,000 when?
It started?
When we started, and when we started, what's that number? 0. We haven't done any quarters yet. So at the beginning. So that's the thing about initial value. Time is 0 for the initial value. 0 is where we always start. Okay, good. How many quarters will this account pay for? You can pay for blank quarters before the money of this account runs out. So this one's a little not so obvious, but we're thinking when we run out of money, how much will we have? We'll have $0. Because actually you couldn't have negative. So 48,000 minus 3,200. X or Q, I guess we could quarters. So how do we solve this equation?
Subtract 4,800.
Very good. So we'll subtract the 48,000 from both sides. This cancels out there. So we get negative 48,000 equals negative 3,200 per quarter. And then what do we do to get the Q by itself? Since we're multiplying, we divide. That becomes 1. And if you take 48,000 divided by 3,200, what do we get?
$15.
15. So we can stay there for 15 quarters. What if we would have got 15.2 or 15.3? Does that meaningful? Probably not, because you can't, when you pay for your classes, right, you got to pay for them. You can't pay for, oh, I've only got money for half of a quarter, so I'll pay for it. So really, if it was 15.3, we could do, it would last for 15 quarters. Even if it was 15.9, we don't have enough to pay for a full quarter, right? So you've got to go to the lower amount. It's not really rounding here. So hopefully, see that? But yeah, we could make it through 15. And then we could go here. It'll give us our answers. I show that to students that, yeah, the teacher's version, I get this. They go, can you make mine do that? I said, no, I can't, unfortunately. But it's a nice little feature. Okay. So we have one last question, which is basically coming back to a similar thing as tuition costs. In 1990, the cost of tuition at a large Midwestern, so here's the year, university was $96 per credit hour. In 2001, tuition had risen to, wow, $250. That's a pretty big jump, right? Determine a linear equation C to represent the cost of tuition in terms of X, the number of years since 1990. So that's part of the reason I did this. Years since 1990, what that means is let's make 1990 year 0. That's really what it's saying. So this becomes year 0. So what would year 2001 be? Year 11. No, good. It's we can calculate it. It's 2001 minus 1990. That's going to be year 11. So what we have, that in year 0, tuition was $96. In year 11, tuition was $250. So we have 2 points. How do we get the equation of the line? We go to our Desmos. And that's why I didn't delete that table, because I knew we were going to need it. I'm going to put these 2 points in and have it give me the equation. Okay, so this is kind of, so it's here. We don't need this one. We don't need this one. So I'm going to put it right in here. Year 0 was what, 96? And year 11 was 250. Now I don't quite see my points because these y values. So what I will do is I'll come here to the little wrench, and I know, okay, my x is okay. My x is going from -5 years to 14 years. That'll be okay. But my y-axis, I need to go at least to 250. So why don't we go to 300? And as soon as I do that, I see my 2 points. The initial value was 96. Year 11 was 250. Notice I turned my equation creator off, but if I turn it, as soon as I click on it, it's been turned on. There's the line that connects those 2 points, and I've got my equation right here. Y equals 14x plus 96. Is the m. And what does those things mean? The initial value is 96, right? That's that first point, 0, 96. 14, that's the slope. So what did that mean is happening each year? It's increasing by $14. Your tuition rate went up for that. Now that doesn't sound too bad, but it seemed like a pretty big jump to go from 96 to 250, but I guess 14 a year, maybe that's not too bad. But actually, we haven't had a tuition increase in a long time here, or have we? We just had one. well, last year I could have said it's been a while. I think that was the first increase in a while. Um, so we don't always, get them every year. But anyway, so 14x plus 96. So we're not quite done yet. That was just part of the answer. So we put that in here. Now we have to be careful they're using x and c. So 14x plus 96. Put that one in there. And again, I'll just, as we go, that's what they wanted. In the year 2003, tuition will be what? So 2003 would be year what? 13, good. Because 1990 to 2003. So what we do is we plug in 13 into this equation. So that's 14 times 13 plus 96. The other thing I'll show you here, once you have the decimals on here, so notice this was 11, you can actually go along here and come to 13. It's $278, right? So you could do the calculation method or you can use the technology method, 278 when x is 13. That's what's nice about these two lines. Again, it's assuming that things continue as they did, which sometimes is true and sometimes not. But that's why I have you use the technology, because it's very helpful. In the year blank, tuition will be 376. We can see that's going to be into the future. I'll show you a way. Okay, so what are we doing? We're solving this equation where 376 is equal to 14x plus 96. Now you can do that, but I'm going to show you if you come back to Desmos. Since we have our line here, as long as I can go up to, 376, right? I can put in a horizontal line, y equals 376. And notice what happens. What do you think our solution is going to be? It's going to be where the two intersect, right? In 20 years, we're at 376. So here's a graphical way of solving things. So I want you to see, we live in a time when there's a great amount of technology. Let's use it, Yeah, we want to understand it, but I tell you what, if we keep going back and learning over and over again what they learned 500 years ago, can we get very far forward? Not really. Let's just take what they did and build on it. Yes?
So are you supposed to take that, is it saying in year 2020, or do you have to take 20 and add it to 90?
20 and add it to 1990. So that's 20 years since 1990. Good question. So see, we still need to think. We can't, it's not completely artificial intelligence, but it's got some intelligence, but we are the more intelligent ones. So yeah, so it's 1990 plus the 20, which would be 2010, right? 2010. In the year 2000, or 2010, yeah. And again, we could see that here. So now we've got everything correct, but I want you to, part of what I want you to learn through this is how to use the technology. If you're more comfortable using something else, that's fine too, but as you get comfortable with the technology, because we're going to pick up again in lesson 4, we're going to be using this Desmos technology to do even more amazing things, not just lines, but graphs and all sorts of stuff. And that's the power we get when we use the technology. Okay, so that's the 6 questions. If you go through the homework, you'll see this is pretty much it. There'll be a few things to kind of figure out, but again, goal is that you work through it. You learn a few new techniques, maybe using the graphing calculator. You get through it, get to 70%, you're good, and you get exposed to something. We'll come back when we get to the midterm exam. There'll be a review session. You go back, you review it a little bit. You will get to use a page of notes for your for the midterm exam and for the final exam, both sides, front and back. So you can start that note sheet now if you want, or later. But we're not testing that you know everything, like you're going to have to apply it, but that you've done some of these things, and that with a few notes you can go back and do it. Because when I was doing financial planning, oftentimes my boss would ask me to do something, and I would think back to school. I would go. I had a book I hid underneath. I didn't want him to know I go look it up. He probably didn't care that I had to look it up, but he thought I was smarter because he didn't know I was having to go to the reference book. But that's what you do. You go back to your references. You look it up. Oh yeah, it's this equation. And you look smart. However you want to do it. But we're all doing it. We're using our tools. So you get the tools for that. And again, this class, as long as you keep engaging, keep coming as you're coming, or if you're picking this up as a recording, that's fine too. As long as you're engaging, you will learn it and you'll be in good shape. So be here if you need to be here. Again, today is Thursday. Tuesday, we'll be back. It's a tutored math section. So, if you get on it over the weekend, you get it all done. You don't have to come if you don't want to. Someone came and they said, "I'm all done. What do I do?" I said, "Well, you want to work on the next one?" "Yeah, let me work on the next one." He got that one done too. So that's why he's probably not here today. So, and you can work ahead, but just whatever your comfort level is, but just keep coming and keep on track. The worst thing that happens is, okay, I can pick up later. You get 2 or 3 behind, then it's not. But if you stay on track, it shouldn't be too difficult. But the thing is then, oh, this is easy stuff. But if you miss a couple, then it doesn't become, it's not so easy. But anyway, that's the goal. So that's what we have. We still have, I'll be here 45 minutes. I got a class after this, so there's no place I can go. So you're welcome to stay and keep working on things if you'd like. If you want to go take a break, get some lunch, whatever, come back later, you could do that, or go and see me Tuesday, or see you next Thursday, whatever works for you.